Hello everyone, you should have your notes packet in front of you. Today we're going to do a real brief video about the rational root theorem. So here's the rational root theorem. You don't feel like you need to write all of this down. I just want to make sure you get the main parts. Suppose that a polynomial equation has integer coefficients and it has the root h over k, where h and k are relatively prime integers, meaning they have no shared factors. H has to be a factor of the constant term of the polynomial. K must be a factor of the coefficient of the highest degree term. This is very useful when you have to solve higher degree polynomial equations. Again, don't feel like you need to write all of this down. Let me show you some examples and see if you get the idea. So before we get started into showing examples of the h over k, it helps for you to know how many solutions could a particular polynomial have. If we have a polynomial that's x to the fourth, that's the highest degree, that means it could have up to 4 solutions. Something that's x cubed could have up to 3 solutions. Now it might not have 3, it might have 2, it might have 1, it might have none, but it can't have more than 3. Same thing with x to the fourth. It might have 4, it can't have more than 4, but it might have less than 4. So for example, here's if we have to use our h over k rule that I talked about earlier. If you have a polynomial x cubed, and we want to state the possible rational zeros. These are just the ones that are the possibilities. We don't know if they're the real solutions. We just know these are the only possible ones. The first thing you do is you look at the leading coefficient, and that's 1. And then you look at 5, the end, and that could either be 5 or 1. And of course, it could all be pluses or minuses. To make a list of the possible rational zeros, you would take the 5 and the 1, and you would divide by the plus or minus 1. And that gives you possible rational zeros of plus or minus 5 and plus or minus 1. Those are the only possible answers. Then, let's do another example. State all possible rational zeros for this one, 6x cubed. Based off of that, then looking at 6 has possible factors, 6, 3, 2, 1. 2 has possible ones of 1 and 2. Those are the factors of 2. Then the possible rational zeros of this polynomial would be all of the plus and minus 2 plus or minus 1 divided by all of the other ones. And then you can make a list of the unique factors, unique rational zeros that work. So the ones that work would be 2 divided by 6, which is 1/3, 1 divided by 6, you can see that on the list, 2 divided by 3, 1 divided by 3, 2 divided by 2, 1 divided by 2, 2 divided by 1, and 1 divided by 1. That's how you go about generating your list of possible rational zeros. You can use those possible rational zeros to help you solve polynomials. Here's an example. If we have an equation, 4x squared plus 3x minus 1, the factors of negative 1 are plus or minus 1. The factors of 4 are 1, 2, and 4. Therefore, the possible rational zeros, we can make a list. The green ones, are the blue ones. The blue ones divided by the green ones. 1 divided by 1 is 1, 1 divided by 2 is 2, 1 divided by 4 is 1/4. So those are your possible rational roots. Now we would use synthetic division to find which ones work, because we have a list of 6 possibilities, and we know there can only be 2. So we would use synthetic division, and first we would try 1. And you can see we have a remainder of 6. So that doesn't work. Then we try with negative 1. That has a remainder of 0. So that works, yes. And that leaves you with 4x minus 1 equals 0. We solve that, and we can figure out the other one. And look, x equals 1/4 is also on our list. So our answers are negative 1 and also 1/4. Let me do another one. X cubed plus 2x squared minus 13x plus 10. H, the factors of h are 1, 2, 5, and 10. The factors of k are 1 and negative 1. Therefore, the possible rational roots would be h divided by k. And you get a list of, those are your possibles. You have 8 possibilities. We need to check and see which ones work. So first I would try 1 synthetically, and it works right off the bat. The very first one works. Then you're left with x squared plus 3x minus 10, which can be factored. And if I factor it, I get x equals negative 5 and x equals 2. So the ones that work are negative 5, 2, and also don't forget the 1 that you plugged in synthetically. Alright, let's do another one. X cubed minus 4x squared minus x plus 4. Factors of h, 1, 2, and 4. Factors of k are 1. Do the division, h divided by k, and you get 1, 2, and 4. So 6 possibilities. Synthetically, 1 works the first time. I always try 1 first, and it works this time. We get a remainder of 0. Change that into an x squared minus 3x minus 4, factor it, and there's your answers. So the rational root theorem helps give you a list of things to try, and then synthetically you just try them until they work. Here's another one. Factors of h, 1, 2, and 4. Factors of k are 1 and 3. If I do the division, h divided by k, I get these possibilities. This time we have 12 possibilities. So we're going to try negative 1. I tried 1, it didn't work. I tried negative 1, and it worked. To find other roots, you can use synthetic division, or you can simply, like if I were to try 2, using 3, negative 8, and negative 4, it works. It should be positive 4. The blue should be a positive 4. Or I could have simply factored it using factoring, and I'd have gotten the same answers. So the actual rational roots are negative 1, 2/3, and 2. Okay, let's try another one. This time we have x to the 4th. Still the same rules. How many answers possible? 4. Factors of the last term, plus or minus 1, plus or minus 4, plus or minus 2. Factors of the first term, plus or minus 1. Possible rational zeros, I do the h divided by the k, the last term divided by the first term, and I get 6 possibilities. Now we have to try synthetically to see what works. So first I'll try 1. So if I try 1 synthetically, plug them all in, do my synthetic division. I'm going to go through this kind of fast because I know you guys are good at this by now. It works. I get a 0 at the end, so that means 1 works. Then I'm left with this new polynomial based off of what's underneath the synthetic, and we can try it again. We can keep going. Let's set it up again. Let's do one more round. So I'll try negative 1 this time. Bring the 1 down. And negative 1 also works. So now we're left with x squared minus 4x plus 4. That, don't forget the x plus 1 and the x minus 1 from the 2 previous synthetic divisions. Factor the x squared minus 4x plus 4, and you get the complete factorization, x minus 1, x plus 1, x minus 2, x minus 2. So x equals plus or minus 1 and plus or minus 2. That's the way we use the rational root theorem to help us factor these things. Find all the zeros. We'll do one more example and then I think I'm going to be done. How many answers? 4 possibilities. Factors of the first to the last term, 1, 2, 9, 3, 6. So lots of choices because 18 has lots of factors. Factors of the first term are just plus or minus 1. So my possible answers, I have 2, 4, 6, 8, 10, 12 possible answers. Now I'm going to start trying them synthetically. So first I try 1. So here's the synthetic division. Bring that down. Do the synthetic division. Didn't work. Sad face. Okay, let's try again. Negative 1 this time. Bring that down. That works. All right, so I'm left with x cubed minus 2x squared plus 9x minus 18. So now I'm going to do synthetics again. No, actually I'm going to factor by grouping. Notice this time I can factor by grouping. If I factor an x squared out, factor a 9 out, now I've got it completely factored. So my answers are negative 1, 2, and plus or minus 3i. And there you have it. So now you can do the 4 problems that are on the back